That said, I'm actually not going to talk about the cluster storage solution very much by itself. Last year I was here, I couldn't talk about it because I just joined the company and everything was still under NDA. So I was talking about what we did back at Sun, which was nothing I'm too proud of anymore, even though I was proud of working for that company. But today I want to talk about some of the things that I've come to realize as a follow-on from last year is important when you start doing these things. So when it comes to reliability in file systems, specifically when you have a Lustre file systems, and as we heard from Brent earlier on, Lustre now never breaks down. It's fully stable. It will, keep almost 100% uptime. So if we have troubles with our file system, or if we get to my secondary title, it's obviously due to the hardware, right? So it wouldn't be the software that goes down, because we know that works. So what is it wrong with the hardware, and why does hardware actually fail out there? So, and this is where I wanted to do a little bit more than I'm allowed to, so I'm not going to speak about any of the projects we're working on and anything about where these would go. So I have a system which is currently under pre-RFP that I want to talk about a little bit. The whole concept about this system is that it will be a large, fast file system because there are requirements that goes beyond the normal, I would say the normal data center requirements. I guess you're all familiar with the system? The Milliard Gigantobrain? So this just goes to prove the fact that the computer business is going downstream fast. And I had actually expected a little bit more. So nobody ever read about these systems, Deep Thoughts, The Hitchhiker's Guide to the Galaxy? God damn it. Any which way, we already have an RFP for this system, which will be a fairly fast system. It's not really very much out of this way, but it's kind of a prototype system for these things. So having a 10 petaflop system is not really that strange. We've seen more than one RFP. We heard about some coming in the 20x beyond that. But one of the things that really gets driving these things is that the data requirement gets bigger and bigger. So if we actually have to do a terabyte per second, and we know there are some around doing that, what would that actually look like from a hardware point of view using today's technology? Well, I based it on the solution that we are currently having in the market. Because I can't really talk about anything else. But I can talk about that system. And in order to get to 1 terabyte per second, we would need about 42 racks of storage. We would need about 27,000 hard drives. We would need about almost 50 metric tons of hardware. And we would need a fair amount of power as well. Now, all of these things put together in a fairly dense platform means we've got cooling issues, we've got weight issues, we've got power delivery issues, etc. Nothing too unusual for this business. But when you start looking at the actual metrics, I mean, you got 27,000 moving parts and not including fans. Now, how many here have had a computer at home with a broken hard drive? I should say, anyone who haven't had that? No. Now, if I have 27,000 hard drives in there, I may have a problem. Now, I think that if we look at it from our point of view, where we actually build these types of solutions, we don't think it should be that big of a problem. So, one of the things we actually did, we took a small brother this, ran it through some simulations on what would it look like with the mean time between failures that we have on our equipment, with the testing we do, with the enclosures we have, and we have a lot of data statistics on these things. We would actually, under a 30-day run at full tilt, be able to keep the hardware components. We're not talking about file system here. We're talking about hardware components at a 99.9 level active. We would lose 11 drives out of 27,000. Well, actually 17,000 here. 11 drives out of 17,000. Now, that's below 0.1%. That's really a good number. If you look at the market as such, you would probably see that the numbers are nowhere near that good. And that's because there are differences in how we actually develop these systems. That's one of the things I want to talk about, what we actually do. Now, coming from Sun, how many here was here last year heard my discussion about what happened when Sun brought up Ullage? Nobody? Don't be shy, come on. There was a lot of people here, right? When we powered that system on, we got 300 drives that actually went down on power on. Now, that's not what I would call a stable system. Here we got 11 that breaks within the first 30 days of usage. That's a pretty good number. So how do we actually do all of these things? Now, I used to think that Sun was a really good technical company, did a lot of really good innovations, quality products and so on. And then I joined Cyratex, for whom testing is a religion. We test it, and then we test it again. And by the way, we've got to test it 3 more times before we start testing it again. And then we test it again, and then maybe we might allow a customer to buy this stuff, but we probably want to test it 2 or 3 more times before we actually sell it to anyone, because that's how we do our business. I won't talk too much about that. I actually have Steve coming up later talking about how Cyratex works and why we are the biggest OEM company in the world from a storage point of view. But what we actually do, we test every component, and we test it to such a degree that it almost becomes ridiculous in my mind. But we test the hard drives. Why do we test the hard drives? We get them from manufacturers that already tested those hard drives. I'll get to that. We test the enclosures. We test every piece of embedded software in there. We test every component of the software. As Brent said, they've been testing Lustre to a humongous extent. We've actually spent a number of hundreds of thousands of hours total testing Lustre as well. And fixed something, made some other discoveries, etc. We're part of this community. But it doesn't just go that far. We test every other component, even things that aren't really ours, like the racks, the power distribution things, the configuration systems. Everything is tested before it leaves our factory. And that's kind of what I want to tell you a little bit about how we do our things. So first of all, why do we test things differently? Now, first of all, we've got the division at Freudian slip. We've got the division at Cyratex that does the hardware, enclosures. We actually shipped 4.1 exabyte of storage last year. We shipped over 5 million drives last year. I mean, that's a lot of drives, and half of you have never heard about us. Kind of weird. But there isn't hardly a NetApp system out there that doesn't run our systems. IBM run our systems, HP run our systems, Dell run our systems, everybody runs our systems. They may not say Cyratex on the front, but who cares? It's our stuff. But we also have another division which is more interesting, which is the one on the right up here, which is the test equipment part. So that means that half of every 3.5-inch industry drive out there is tested on Cyratex equipment. And at the moment, business is pretty good because half of our equipment is flooded down in Thailand. So, but it kind of goes to the fact that we know how to test hard drive because we build the equipment that tests hard drives. And obviously we use it internally as well to test our hard drives, because it's not that we don't trust our vendors, but we know that sometimes there's a bad batch here and there. Sometimes a lot more than a bad batch, but sometimes there is a bad batch, and we want to weed that out before we actually put it into one of our storage enclosures that we sell, because if we ship a bunch of enclosures to IBM and they turn out to be bad, they get kind of cranky on us. And we don't like when they're cranky because that's bad for business. So we start these testings. Now, we have facilities all over the world. In Europe, everything is built in Havant, which is in south of England, where we test all of these things before they get built. Then we test it when they get built and when they have been built, and then we test it again, as I said. If we look at what we do from our enclosure point of view, we not only test every component. I want to point to this part where we actually start testing the hard drives. So what we actually do is we put the hard drives into an enclosure, and we start doing I/O load for 24 hours. But we just don't do that. We actually increase the temperature of that rack to about 45 degrees while still doing I/O. And then we push it back down to 5 degrees centigrade and do I/O all the time. And back up again, and back down again for 24 hours in order to really, really test the life out of that drive. If the drive survives that, it will pretty much survive everything. Now, we actually return more drives to our vendors than some storage companies ship totally. So, and they're fine with that. They say, yes, we will take your drives. We trust you. You know how to do these things. Where they actually sell those drives to after we return them, I don't know, but you might want to think about that. So when we look at this, and this was actually a study done not by us, but by NetApp, who up until recently was our absolute biggest customer. And we look at the actual failure rates. So you see the span where the normal industry average failure rate is about 3 to 4%. If we look at this line, say in the enterprise storage, you can look at the numbers. Over the first couple of years, we are 0.46, 51, 73 points of a percent in failure rate in this study done by NetApp. Actually, the real numbers from our own investigation is 0.2 to 0.3 over the first 3 years. That's how few drives will actually fail during the first couple of years of life cycle. That infant mortality rate that we have means that we got systems that will run more stable, that will run with a lot less failures. Now, going back to the Gigantobrain, if I have 27 drives in there, and I have 5% breaking every year, that means a lot of drives have to be replaced, which is doable. We got cheap labor to do that. Andreas is over there. He's my cheap labor. That's sorry, Andreas. I promised to be nice. Sorry. But that is kind of one of the things that is a cheap enough thing to do. However, if every time one of those drives break with the sizes of these drives, and I suddenly have a file system where one of the OSTs is rebuilding for 18 to 24 hours, depending on the settings you do, if I have performance settings in there, that means that my file system will be suboptimal for that time. Now, if I got 2 or 3 drives breaking every day in a system, which is not unlikely in certain vendor system, the total time where my system will actually perform at an optimal level is 0. And that's really not really what our customers want. They want enterprise quality. So this is important, and we think that one of these things. Now, the other things that we do differently is we don't ship 1 million cardboard boxes to a customer. Send in a number of highly skilled engineers who spend 3 months camping in your data center building your system. We build this in our factory and ship a pre-configured system to the customer. That means that we actually get to a customer site. We unpack the rack, we put the hard drives in, we power it on, we connect it to the clients, and we have a system up and running within an hour, at best. Sometimes we actually break for coffee in between, so it takes 2 hours, but it's that time frame. Now, most of you who have actually worked with a large storage facility system knows that a couple of months is normal time to get things up and running. But we do everything in a factory where everything is pre-integrated. As you can see, we even build it in our shipping boxes so we can test everything, and everything is pre-integrated. The facilities we have is like a data center. It has 3-phase power, it has water-cooled rack doors in there, so we can actually test the cooling facilities and everything, so that when we run a benchmark on these racks, we can measure how much heat they are actually generating, how much cooling we get into the system, and we can keep the room neutral at that point. And that makes a lot of difference for the resilience of the systems as well. The fact is that once we built these systems, we can actually start testing everything. We install a file system on them as per the customer's requirements. We install all the software needed. And actually everything is automatically installed by a software installer with a nice graphical GUI, by the way, but there is a command line too, so that works too. Once we've done that, we put it through 30 days of soak test. We run benchmarks on it, we run IR on it, we run a lot of testing on that system to make sure that it will actually deliver the performance we claimed it would to the customer. So we know when we ship this out of the factory, it will actually perform as spec'd, and not something we hope it could, and if it can't, we'll tune it a little bit, and we tune a little bit to more. Now these systems come out of the factory pre-tuned, pre-built, pre-wired, pre-tested. So when you get a system on your floor, this is actually what you get. You get a rack where you can actually fold down the front door, roll the rack out nicely, and you get a box with the drives because we actually don't want to ship it with the drives in the system. We don't have a problem with that, but if you tell a shipping agent that, oh, we're going to ship a rack that's going to weigh 1.3 metric tons on a pallet, they get kind of scared. So we kind of split it up a little bit. But this is what you get. You don't get a million cardboard boxes. You don't have this situation where one of the engineers is running around like crazy because somebody removed the boxes and he forgot one cable in one of those boxes. One of those 1,000 boxes we have in the storage facility outside is the last cable is missing. Everything here is really pre-cabled. Again, one of these things. Once we've soak tested it, we pack the drives into close it and ship it up like this. And it really makes installation really easy. Now, when you get to a site where you need to install 27,000 drives, and honestly, the install team at Cybertex Europe is Andreas and myself. So, you know, that's pretty much it. Now, I don't know if you've ever have to do that, but putting hard drives into enclosures by hand, one at a time, it's easy enough with one storage device. After a rack with about 700 drives, at least my shoulders were aching a little bit. My hands were getting really numb. And the one thing you don't want to do when you install a system is drop a drive on the floor. Because that is, you know, for all intents and purposes. And then you get someone like Hussein standing over your shoulders looking all the time, and you definitely don't want to make a mess out of yourself, right? So we took it one step further. We actually made sure that we had a mechanism for doing these things. And just to give you an idea of what that looks like, this is our enclosure. This is how you actually pop up the drives. And we have a speed loader for this. Now the speed loader is made so that it can't actually drop a drive. This is actually the shipping container for the drive, so it's exactly the same dimensions as the box inside, which means that it's really easy to do. That also means there's no fingers on these things. There's no gloves that I have to use in order not to get, you know, human debris on a hard drive. I just use the speed loader. Fits perfectly, goes into the system. That means I can do 7 drives at a time. It pretty much means I can fill. Yeah, well, normally we have somebody holding that one down. And then we just lock them down, and we're ready to roll. So again, we've tried to figure out every single step of this installation process in order to make it very simple, very easy to do, and something that can be repeatable when we actually install things. Now, we're shipping things in racks, right? And I don't know how many of you guys have had issues with shipping agencies that actually deliver things to your site. We want to make sure that our rack can actually take the punishment of an Italian driver on a rush delivery from Milano up here. So we actually loaded up a rack with hard drives, everything. The only thing we didn't do, we actually didn't power it on. But we wanted to see how that rack would handle a metric tons of equipment. Oops. What happened? Come on, back. That's interesting. So we loaded that rack up, and we start shaking the rack. This is an earthquake simulator. Nothing happens. Let's crank it up. Let's crank it up some more. This is fun, right? So this is about 6.3 on the Richter scale now. And it still takes a punishment. So HPC builds some damn good racks. However, at the end of this, things started sounding a little bit more noisy than it started when it actually had noise turned down. So you can kind of see it, it's a little bit hard, but in the end, the back rack mount suddenly breaks down because it actually couldn't take the load of this. So what happens is that we have to reinforce these racks with another 32 rivets before we send it out, just in case we have a bad driver out there. Well, we looked at it, you know, so when you actually do a factory tour in Havant, this is part of the ride. Could be, at least. This is what we sold to CEA. Oh, sorry. So anyway, to summarize a little bit, you know, we are kind of uptight about testing. And the reason for that is that we really feel that testing is a way to get to a solution. So the fact that we have a storage solution that is built, designed, and manufactured by the largest OEM in the world for storage, even though the supercomputing storage or the Lustre appliances is not really the biggest point. We do have an entire stack that we've designed from the ground up. That also means that we support everything from the unified system manager, which is actually something running underneath the file system, is run in the SAS chain. Just to put an idea what this does, it actually manages every single component of this, even though the system hasn't been booted up on a server. It will even do things like monitor every single drive. If a drive becomes unresponsive, it will power cycle that drive automatically, twice, to make sure that it might start up again. Now, this is something we've been shipping with every single enclosure for the last 3 years. So it's nothing new, it's not something we developed for this. But from a HPC point of view, where we might not be that used to very stable hardware management solutions, we have that as an, given on these systems. We wouldn't ship a system without it. We obviously run Linux, everybody does, but we do actually build the Linux ourselves to make sure that we have every single component tested. We actually replace certain things in there because we think that we actually know how to do some of these things better. That also means we can support it. We have the RAID stuff in there. We've been doing RAID for a long time. I mean, Cytotex has been around for 25 years, so it's a company that's been around. And then obviously we have the Lustre file system. And we do use the standard source tree that everybody else uses. We're definitely part of the community, and we see no reason why we couldn't just use that. We will build it ourselves, we will test it ourselves, because we also support everything up and down. And that means that from a customer point of view, you get one throat to choke. There is one support contract that will cover the software, the hardware, Lustre, everything from one vendor. It also means that we can kind of control some of the release trains, some of the other features in there. We have a very different roadmap going forward for these things than a lot of the other vendors out there. But in the end, it comes down to one thing. We want to make sure that a customer gets our systems on site. He may call us 11 times in the first year to get one hard drive rebuilt or replaced every time, but that's about the amount of information or interface we want with the customer. We really want this system to be an enterprise level quality system within a data center without having to have 10 people on site, because that's not really scalable. And that was actually my last slide, so I kept within the time. So, questions?